Alright, so multi-protocol label switching, MPLS. We saw a brief introduction in the previous class. This is going to be a recap plus few more extra things. But this class is going to give you an overall picture of MPLS for sure. Why MPLS, what is MPLS, where is MPLS, what all involved in MPLS, what all we can do with MPLS. All those things can be seen in this chapter, in this 11 slides that I have prepared. What is MPLS? As we all know, it is multi-protocol label switching. Because of this, the network becomes faster. As the network is becoming faster, we can have more data now. When the network is slow, you cannot have more data. When the network is fast, you can add little more data. Because the network is able to handle, that's why it is fast. Alright, so MPLS is used wherever scalability is needed. I don't want to buy a new device. I just want to improve scalability somehow using what I have. Then you can go with MPLS. And we learned that this works in the layer between layer 2 and 3. When we enable MPLS, where does the MPLS header fits? It fits in between layer 2 and layer 3. That's why it is coming under the category of switching, not the routing. MPLS label switching. So we need MAC address. We also need labels. The advantage of using label is there is no need for reading the entire IP layer header in the incoming packets. Just by looking into 32-bit MPLS header, routers can determine the exit interface and the gateway. So it is faster. High performance is achieved. Every router now is going to only do 32-bit reading in order to know the destination, not the entire layer 3 header to know the destination IP. Here it is not going to learn the IP, but it knows the label using which the receiving router will know the IP. The receiving router will know the destination network just by looking into the label. Now, when you have Ethernet wire, you can have MPLS. When you have ATM, then also you can have MPLS. When you have frame relay as layer 2 encapsulation, then also you can have MPLS. You know the reason why. Because MPLS is working after, above layer 2. So whatever the layer 2, it doesn't matter. If you have Ethernet, okay, no problem. ATM, no problem. Frame relay, no. That is another reason why it is called as multi-protocol. Not only that, it can work with IP protocols like OSPF, EIGRP, ISIS, but recommended is to use ISIS and OSPF. Recommended to use a link state routing protocol. You know, because you got all protocol support, the word multi-protocol comes into picture. It supports all layer 2 encapsulation, all layer 3 protocols. That's the reason why the name multi-protocol label switching. As we already know, when we enable MPLS, it speeds up the traffic flow. So that makes the network management simplified. How? Just a simple layer 2.5 header is what is used. This picture is a well-known picture for you. We had the same picture in the previous class. when an IP packet is received from the customer, the edge router, the provider edge router, in our case this is the provider edge, this inserts a label and then forwards the packet down. This one receives this packet, reads the label. When it reads the label, it knows the destination. This is the secret. When it reads the label, the secret is when it reads the label, it knows the destination. It knows this label is for that destination, so this is for that particular network, 4444, something like that. Okay, fine, I understood that it needs to go to 4444. What about this guy? What label he gave will be added and sent to this guy. And this guy looks into the packet, reads the label, knows the destination now, and delivers the packet here. This guy reads the label, knows the destination, and when he is about to send out, he finds that that interface has got no MPLS. So it pops the label off and sends only the IP packet. You see, you received an IP packet. Internally, it was only label switching, and when it is sent out again, it is sent as IP. IP packet is received and IP packet is sent. Inside, in between, it is label switching. So the insertion of label happened here, swapping of label happened here, again swapping of label happened here, popping of label happened here. This is the way that MPLS works. Why MPLS? As we all know, it increases the speed, as a result the performance is improved. Faster forwarding by label lookup instead of full routing table lookup. This is what people are despised. எல்லா புக்லையும் இதை எழுதி கிறுக்கி வச்சிருக்கிறானுங்க. ரவுட்டிங் டேபிள். இன்னொரு ஸ்டோரி இருக்குது, அதை விட்டானுங்க. See, it's not going to read the routing table now. Look into the routing table in the router. Because in the Ceph table, you already have a label. So using that label control plane, the packets are forwarding, no doubt. But why are you not saying the other side? The other side is, instead of reading the layer 3 header of every single incoming packet, instead of reading the layer 3 header on every single packet, just by reading 32-bit, you are able to know the gateway by looking into Ceph table. So that need to be added actually. நிறைய பேருக்கு இந்த பகுதி தெரியும். MPLS என்ன பண்ணுதுன்னா, இது ரவுட்டிங் டேபிளை பார்க்க வேணாம்ப்பா, லேபிளை பார்க்கும்பா, செஃப் டேபிளை போயிடும்பா. அது பாதி கதை தான். தட்ஸ் நாட் ஃபுல் ஸ்டோரி. மீதி கதையும் சொல்லணும். மீதி கதை என்ன? வருகிற பேக்கெட்டில் எல்லாம் லேபிள் இருக்கிறதுனால லேயர் 3 ஹெடரில் இருக்க ஒவ்வொரு ஃபீல்டையும், தட் இஸ் வாட் கோயிங் டு ரெடியூஸ் லாட் ஆஃப் டைம். That's what going to really increase the speed and performance. Ceph table is already there. No one looks into the routing table even when there is no MPLS. No router is looking into the routing table. Already you got Ceph table. பிரமாதம் கிடையாது, routing table lookup கிடையாதுன்னு சொல்றது. Right? So, I want to say also this one. Every incoming packet, when it is processed, router will not read layer 3 header, because just by reading the 32-bit MPLS header, router already knows the next hop. So there is no need for the IP address, the destination IP address. And there is no need for routing table lookup. It will just look into the MPLS forwarding table or LIFAB, and then the Ceph table, and pushes the packet out. So as it is reducing the time taken, CPU taken, the scalability increases. So this is very good in service provider side if you use. It doesn't mean that you cannot use it in the enterprise side. You can use it. Next, this is a very good feature that comes with MPLS. If you have MPLS, you can have additionally another protocol called RSVP, Resource Reservation Protocol. You can have RSVP, yeah, along with MPLS and BGP, and you can do what? Traffic engineering. We'll learn these things later. I'm just giving you overall today. Secondly, the quality of service. MPLS header has got 3-bit reservation for QoS. We got 3-bit reservation for QoS. MPLS has got 3-bit reservation for QoS. With that, you can also provide a special privileged service for voice, video, and all time sensitive. Yeah? All right. Now, why MPLS? We saw first what is MPLS, and now we are seeing why MPLS. We have seen 4 points. Few more points. VPN support. See, in IP world, in IP network, if you want VPN, then you need to enable GRE. That is an additional layer. When you have MPLS, with that same MPLS you can have what? Layer 3 VPN, Layer 2 VPN. This Layer 2 VPN is what we called as VPLS or VPWS, Virtual Private LAN Service and Wired Service. Okay. VPLS and VPWS. Next is convergence of networks. Like if you have an IP network, ATM, frame relay, and you want to put everything together, no problem. You can have MPLS to connect all of them. But this is not practically seen in the real world. Connecting ATM, frame relay who has got frame relay? Very rarely you can see 1 or 2 here and there. Next is you can have this guaranteed performance. If you want to have less than 50 millisecond convergence, which is guaranteed by MPLS traffic engineering feature called fast rerouting. See, these are all the advantage of MPLS. This is why we go for MPLS. We saw in the previous slide, right? Voice, video, they're all time sensitive. They all need this convergence. Meaning if one path goes down, it should be rerouted to another path. And when it reroutes to another path, it should not take much time. If you ask Darsh, he will tell you. To switch from one ISP to another ISP takes a lot of time. Switch over happens, but it takes time. Convergence time. It should not take much time. It should be less than 300 millisecond for voice and video. Now this MPLS traffic engineering guarantees less than 50 millisecond rerouting convergence. Okay. Use cases. Where do we use MPLS? As we already know, layer 3 VPN, layer 2 VPN, interconnecting multiple branch sites. See, I told you, enterprises will also run MPLS. Traffic engineering. What is traffic engineering, by the way? Traffic engineering is trying to use all available paths without wasting. So if you allow routing protocol, it picks only one path. It picks only one path. Traffic engineering will allow the router to use all the paths, even those paths that is not there in the routing table but physically present can be used. QoS for real-time applications. As I already showed you in the previous page, fast reroute, which guarantees fast convergence, less than millisecond, 50 millisecond. That is what here it is said, prioritizing voice and video traffic. QoS for real-time application. Okay, here is the comparison between the IP routing, meaning normal routing, without MPLS, and the MPLS with MPLS. Without routing, everything is based on the IP destination in the IP header, whereas here it is based on the label. Because the header is too big, it takes long time, so it is slower. This is just 32-bit label switched, so it is faster. QoS here also we have, but it is limited just to IP. Here you can have traffic engineering also QoS. Traffic engineering is difficult in a normal IP routing without MPLS. With MPLS it is easy. For VPN, there is no native VPN in IP. If you want VPN, you need to go for GRE, generic route encapsulation, along with IP header, or another header called IPsec AES. Those are all additional burden. Whereas when you have MPLS, VPN is a byproduct. But again, I told you on the previous class, my friend, VPN means virtual circuit. A state. You can't compare this to security VPN. Here nowhere it is said about security VPN. Now what are the building blocks of MPLS? What all needed for MPLS? First is the label. The label stack, I told you it is 32-bit header. And the 32-bit header has got this 4 section. 20-bit of label, 3-bit of QoS. You can also call it as experimental bit. 1 bit of bottom of stack, 8-bit of TTL. Altogether is 32-bit. So MPLS is 32-bit header. Just 32-bit header. With these things, 4 things: TTL, bottom of a stack, QoS, and label. And you see, for label 20-bit, you can have enough of label. routing table வந்து 2 லட்சம் ரூட்ஸ் இருக்குங்க. 2 லட்சம் ரூட்ஸுக்கும் லேபிள் கொடுக்க முடியுமாங்க மனுஷனால? Why not? Just put 2 to the power of 20, you will know. That many labels it can give. Let's see what is 2 to the power of 20. We don't call BGP simply as BGP. The reason is We use BGP not only just to form neighbor and have some attributes. We have BGP with MPLS to do layer 3 VPN, layer 2 VPLS, VXLAN EVPN, segment routing, and much more. That's why we call it as MP, multi-protocol BGP. As I said, RSVPTE is another building block, LDP is another building block. So by using this protocol, you can have MPLS label-based forwarding plane, which is nothing but data plane. Forwarding plane is nothing but data plane, and control plane. அப்படின்னா என்ன சாமி? Control plane means in router which controls the direction. We used to say routing table. But now, because you are going to have MPLS, routing table will not be. We saw here. Routing table lookup. Instead of routing table lookup, what it does? Label lookup. Which means what? You are going to have a control plane. You will have a control plane with labels, which we called as MPLS binding table. Alright? So we will have for every destination route, exit interface along with the label. And the forwarding plane, which is Ceph, along with the label, will be referred before forwarding the packet. So forwarding plane is the data plane actually. First the control plane and then the data plane. All these are label based. Oh, this is again known story for you. Where MPLS is used. Wherever you want MPLS VPNs like layer 2, layer 3 VPNs, traffic engineering, means MPLS traffic engineering using RSVP, quality of service, fast free route, right? All this place MPLS is needed. Now, once you are master with MPLS, you can also have something called the segment routing with MPLS. In service provider, I'll teach you this. Service provider has got this additional MPLS topic called segment routing. That is also a MPLS only, but the way that labels are used is different. Yeah, same label only, but the is different. I'll give you an example. If you go to a city, either Chennai or Bangalore or Ernakulam or Delhi or Mumbai, let's say you are new to the place and you do not know where to go, what to do. Now you will start asking, you will take one bus, take a ticket and get down in a station, bus station, and then you take another bus, take another ticket, and then get down in another station, take another bus, another ticket, and then you get down in the final spot where you want to meet someone. You see, in every bus you took ticket till you reach the destination. In every bus you need to get ticket. But it may be there in India, I'm not sure. I did not travel in bus for last 20 years, so I don't know. When I was in Zurich, Switzerland, we just buy one card and then I go to the station there. There will be one punching machine. I punch my card and wait. The train comes, I get in. And then I get down from the train. Again I punch the card. So more the punch I do in the card, the money in the card get reduced. I'm not talking about card like ATM. In Dubai, they used to give card like ATM card. There you don't punch, you just keep. Like the one in metro, I think even in metro India, it should be there. I have never traveled in India metro again. It should be there in metro stations, according to me. Like one debit card they will give you, credit card they will give you. In that you top up some money and you travel. That is what segment routing is. You top up all the money, all the ticket that you want for all the stations. And then as you go, you just punch and go. You don't buy a new ticket, no money taking from the wallet, purse, nothing. MPLS, normal MPLS is like, you go in a bus, take a ticket, go to the other bus, swap the ticket. You do, no, label swapping. You don't have such thing in segment routing, no swapping business. So this is the advantage of segment routing. You no need to depend on RSVP or LDP for traffic engineering anymore. How is that possible then to have traffic engineering? You are going to use that link state protocol, OSPF or ISIS database to do traffic engineering. So, if you are going with segment routing, there's a big advantage. You no need to use LDP for label distribution. Why? OSPF is already running everywhere. Let OSPF only carry the label. Why I need another protocol? OSPF anyhow it is going to send a link state advertisement, right? I will just do one extension to it so that it will also carry labels. So when you have OSPF or ISIS, you no need LDP, you no need RSVP. OSPF ISIS, which is running on all router, can distribute the label, can carry the message for traffic engineering, etc. So segment routing really simplifies the net. Ayya kelunga ayya. இல்லை இது லேபிள் டிஸ்ட்ரிபியூஷன் தான் பண்ணுமே ஒழிய லேபிளை ஒருத்தங்கிட்ட இருந்து எடுத்துன்னு போய் அவங்ககிட்ட கொடுத்துருவோம். அப்புறம் அவன் எம்பிஎல்எஸ் ஹெடரில் அட்டாச் பண்ணிப்பாங்க. யூ மிஸ் அண்டர்ஸ்டுட். பாருங்கள், எல்டிபி ஒன்றும் லேபிளை ஒன்றும் லேயர் 2ல இன்சர்ட் பண்ணலையே. எல்டிபியும் ஆர்எஸ்சிபியும் லேபிளை டிஸ்ட்ரிபியூட் பண்ணுது, கேரி பண்ணுது, எடுத்துன்னு போய் அவங்ககிட்ட கொடுக்குறது, அவங்ககிட்ட இருந்து இவங்ககிட்ட வர்றது, வாங்கிக்கிறது, அந்த வேலையை தான் பார்த்துட்டு இருந்துச்சு உள்ளே. அது ஒன்றும் உங்கள் ஹெடரில் 2.5ல மெயின்டைன் பண்ணிட்டுலாம் கிடையாது. அந்த மாதிரி OSPF and ISIS is not going to create a label layer 2 header for you. My friend, you still have MPLS. I'm not saying you are removing MPLS. Segment routing in IPv4 is possible only if you have MPLS. You have MPLS to give you a label header at 2.5. But எந்த லேபிள் அங்கே போடுறது, அதை யார் எடுத்துன்னு வந்து கொடுக்கறது? Who will bring me the label? LDP. If I have traffic engineering, RSVP. But segment routing says, நீங்களாம் போடா, நீங்களாம் எனக்கு ஒன்றும் தேவை கிடையாது. நான் என்கிட்ட LSA இருக்குது, லிங்க் ஸ்டேட் அட்வர்டைஸ்மெண்ட்டு. ISI சொல்ல என்கிட்ட LSP இருக்குது, லிங்க் ஸ்டேட் பேக் ப்ரோட்டோகால் டேட்டா யூனிட் இருக்குது, LSP. அதிலே நான் லேபிளை கேரி பண்ணிப்பேன், ஒன்றும் தேவையில்லை உங்களுதுலாம் அப்படின்னு LDPயோ RSVPயோ ஒதுக்கி வச்சிருது. Did you understand now? Thus, it was wonderful question from you. That was really nice. பாருங்க ஒரு கேள்வி. OSPF லேயர் 3லலாம் ஒர்க் பண்ணுது. ISIS ஆச்சும் பரவாயில்ல, எந்த லேயர்லாம் ஒர்க் பண்ணும், அது லேயர் 2லேயும் ஒர்க் பண்ணும், லேயர் 3லேயும் ஃபிட் பண்ணலாம். ஆனால் OSPF எப்படிப்பா சொல்கிறீங்க நீங்கள் அப்படின்னு ஒரு கேள்வி கேட்டார். நம்ம கேள்வி அது. OSPF லேயர் 3ல தானே ஒர்க் ஆகுது, MPLS 2.5 லேயர் இல்லையா? ஆமாம் 2.5 லேயர் தான் இப்பயும் அந்த எம்பிஎல்எஸ் இருக்க தான் செய்யுது. நம்ம அதோடு எடுத்து போட்டுருலையே. இந்த லேபிளை எம்பிஎல்எஸ்க்கு கொடுக்குற பையனுங்க 2 பசங்க இருக்கிறானுங்க, எல்டிபி ஆர்எஸ்விபின்னு. அவனுங்கள தான் நம்ம என்ன பண்ணியிருக்கிறோம், போதும் போதும் உங்கள் சர்வீஸ்லாம் போதும், வி வில் மேனேஜ் அவர் செல்ஃப், எப்படியும் எல்லா ரவுட்டர்லேயும் ஐஎஸ்ஐஸ் ரன் ஆகுது, இல்லை ஓஎஸ்பிஎஃப் ரன் ஆகுது, அதை வச்சே நாங்கள் பார்த்துக்குறோம் அப்படின்னு சொல்லுது இந்த செக்மெண்ட் ரவுட்டிங். ஃபைன். Now, because the segment routing is making things more simple, அது எப்படி சிம்பிள் ஆயிடுச்சு? அதான் எல்டிபி வேணான்ட்டிங்க, ஆர்எஸ்விபி வேணான்ட்டிங்க, அப்போது சிம்பிள் ஆயிடுச்சு. அது ஜாஸ்தியாக ப்ரோட்டோகால் சேர சேர காம்ப்ளிகேஷன் ஏறினே போகுது. அது வேணான்னு சொல்லிட்டிங்கன்னா அப்போது கொஞ்சம் நெட்வொர்க் ஆப்ரேஷன் சிம்பிளிஃபை ஆயிடுச்சு. சிம்பிளிஃபை ஆயிடுச்சுன்னா இந்த சாஃப்ட்வேர் டிஃபைன் பசங்களுக்குலாம் ஒரே கொண்டாட்டம். அவங்களுக்கு ஈஸியாக புரிஞ்சிடும். அவன் என்ன பண்ணுவான், டெவலப் பண்ணுவான், ஆட்டோமேட் பண்ணுவான். காம்ப்ளிகேட்டடாக லேயர் மேலே லேயர் லேயர் மேலே லேயர் இருந்துச்சுன்னா சாஃப்ட்வேர் டிஃபைன் வந்து அழுவோம். நிறையா லேயர்ஸ் இருந்துச்சுன்னா சாஃப்ட்வேர் டிஃபைன் வந்து வேலை செய்கிறது ரொம்ப கஷ்டம், காம்ப்ளிகேஷன் அதிகமாகிடும். ஸோ செக்மெண்ட் routing, when you use segment routing, you reduce this complexity of network operation. As a result, the software defined team need to just to develop automating tool for 2 layers, isn't it? MPLS header, that is one layer, and then it needs to be added to the 2.5, and that label need to be carried through OSPF. So in the 2 operations are saving SDN. So easier develop பண்ணிட்டு போயிடுவோம், ஆட்டோமேட் பண்ணிட்டு போயிடுவான். அதுதான் மெயின் ரீசன் ஆக்சுவலாக செக்மெண்ட் ரூட்டிங் வந்தது. அது வந்ததும் வந்துச்சு. எஸ்டி வேணும்னு சொல்லலாம், ஏசிஐன்னு சொன்னான், எல்லாம் இந்த டெக்னாலஜி தான். இந்த செக்மெண்ட் ரவுட்டிங் வந்து தான் அதுக்கெல்லாம் ஓப்பன் பண்ணிச்சு டோரை. செக்மெண்ட் ரவுட்டிங் வரலன்னா எவனும் எஸ்டிஏ வேலை பற்றியும் பேசியிருக்க மாட்டான், ஏசிஐ பற்றியும் பேசியிருக்க மாட்டான். Right. So what is MPLS? Label-based switching technology. Why do we need MPLS? For speed, scalability, QoS, VPN, traffic engineering. How is that happen? By distributing the label, MPLS can develop a label-based control plane, label-based path. We call it as LSP, label switched path. That's how the packets are switched. MPLS remains the foundation of modern carrier network and the stepping stone for segment routing and SDN. Okay, so this is just an overall, right? So we have taken like 6 routers, and now I'm going to start all of them. Meanwhile, let's plan the IP. I'll say 10.12.0.0/16, and we also need loopback interface. Very important, loopback interface should be there for MPLS, and that should be a reachable one from other routers. I'm saying something very important. You should have a loopback interface, and it should be a reachable one from other routers, which means what? If you're running OSPF, you should run on loopback as well. If the loopbacks are not reachable, they won't form neighbor. By default, they form neighbor using loopback. Right, see, I'm going to enable OSPF as the routing protocol along with MPLS, but let us do MPLS separately. I'll finish just basic IP address configuration with OSPF. One single flat area. I'm going to have, see, very important is you must run OSPF on loopback, because that loopback should be reachable. Loopback address should be reachable from the neighboring router in order to form neighbor. They will speak only using loopback. If that loopback is unreachable, if the neighbor's loopback is unreachable, they cannot successfully negotiate. Don't forget that. Now, you see how to enable MPLS. Very simple. To enable the MPLS process, you type MPLS IP. அடப்பாமே இதை கூட சப்போர்ட் பண்ணலையா இது என்ன ஆப்ரேட்டிங் சிஸ்டம் இது இன்டர்ஃபேஸ் F00 MPLS பரிதாபம் அந்தோ பரிதாபம். After changing the operating system, it works. See, this is the command to enable the feature, start the MPLS process. This doesn't mean the interfaces are supporting MPLS. No. The router has started the MPLS process. Without giving this command, you can go to interface and say, I want this interface to run MPLS. When you say this, automatically global MPLS process also gets started. இது இல்லாமலேயே இதை மட்டும் போட்டிருந்தா கூட போதும். அதை போட்டுட்டு தான் இங்கே வந்து போடணும்னு அவசியம் இல்லை. அதான் சொல்ல வரேன். Right. Another thing is you cannot enable MPLS on loopback interface. You know why? Because you cannot do any label distribution on loopback interface. It is virtual interface. It's logical. It's logical. Loopback interface is logical interface. If you try putting this command MPLS IP on loopback, it will show. No, man. You are doing wrong, man. Why, man? Don't do, man. You see, let me show you. You see? எதுக்கு இந்த தேவையில்லாத வேலை அப்படின்னு சொல்லுதா இல்லையா? சொல்லுது. சரி. Let us move on to the other router with MPLS now. In the notepad, I am going to do with MPLS. Now enabling MPLS, soon after config T MPLS IP, and then under the interface MPLS IP. One just command like MPLS IP, if you know, and you know how to enable MPLS. Just one command MPLS IP. Router 2 is ready now. When I paste this, router 2 will be ready. See, there is no command problem anywhere. All the commands are taken. Now you will see LDP neighbor coming up. I told you when you enable MPLS, LDP gets enabled to distribute the label. You see, OSPF neighbor has come. You will see now LDP neighbor. Look at this. And I told you they will use loopback interface to form neighbor, like OSPF. And this interface should be pingable address, otherwise it cannot form neighbor. Because it is pingable, it is forming neighbor. Show MPLS LDP neighbor. You see, it shows that this guy is the neighbor. I told you LDP will use 646 port number. You see 646. Let me configure router 3. F00 of router 3 will have 23.3. F10 will have 34.3 and copy this, put it on router 3. Okay, so going back to copy router 3 configuration, and now going back to the CLI of router 3. Again, I'm expecting LDP neighbor after OSPF neighbor. See, you have formed neighbor with router 2. So there is also another command to verify whether MPLS is running on interface. Show MPLS interfaces. It shows that LDP with the MPLS LDP is working on this 2 fast Ethernet, and it is working, it is operational. Now next is router 4. Router 4's F00 has 34.4. And then router 4's Ethernet 5/0 has got 45.4. Right. So I'm going to paste this now on router 4. I made a mistake. I should say Ethernet, but I just said fast. No, it is correct. I changed Ethernet. Yeah, it is correct. 5/0, no? Yeah, it is up. Correct. Show IP interface brief. Perfect. Perfect. Show MPLS interface. It's working on Ethernet as well as fast Ethernet. Okay, now 2 more routers to go. On F00 we have 56.5. Ethernet has got 45 only, but .4 here. Now this has to go on router 5. It is done. One last router, then we'll do some verifications. F00 will have 56 6. This goes on router 6. That's all. Now once the LDP neighbor comes, we'll do some check. Now you see, I'm going to trace the route. Before that, I want to show you the control plane and the forwarding plane. Show MPLS forwarding. It says that to go to 1111, the outgoing label is 19. It puts 19 and sends to router 5. If router 5 receives the packet with the label 19, you see, receives with the label 19, it knows that the packet is for 1111. So what it does is it swaps with the 18 and sends to router 4. Now when router 4 receives with 18, show MPLS forwarding. When it receives with 18, it understands the packet is for 1111. It swaps with 17 and sends to router 3. And that is how it goes, okay? I don't want to explain all this thing. Let me go to router 6. I think you would have understood by now. When I trace route now, you can see them. Them means who? Those labels. When the trace goes, it carries the label, and that label you can see here. Usually labels were not sent when there is no MPLS, there is no label. But now you see there is a label. Label number 19. That's what we saw here. Outgoing label is 19 for 1111. Now it is putting 18 and sending to 4, and now 4 will put 17 and send to 3. You will see 17. Yeah, look at this. 17. And router 3 will put the label given by router 2. It may be 16. I'm not sure. I have not checked. Okay, it's 16. And now there won't be label when it sends to R1 because R1 is the final ultimate router. We'll talk about PHP called penultimate popping, which has just happened in our another class. Now another binding table is this. Show MPLS binding, LDP binding for 1.1.1.1. No need to put slash, just put 32. Look at this, it says that the outgoing label is 19. That is what you saw when I traced route. You can also cut this and see the entire binding table, entire control plane. This is MPLS control plane. I also want to show you the Ceph table with the label. Show IP Ceph 1.1.1.1. Usually it won't show this label unless you will have label based forwarding LFIB. Any question? I'm going to stop here. The remaining thing we'll see in the next class. Do you have any question? That's great. But though it is a simple lab, I want you to build this lab and keep it ready so that when I do something more tomorrow, you can go immediately and verify them.